Next, we would like to welcome Bartlomej Nowak on stage, who this year is investigating deep reinforcement learning. Let's see what he has to say about it.
Welcome everyone, I'm Bartlomej Nowak, and today I'll be presenting my project about controlling robots with reinforcement learning. So what even is reinforcement learning? Well, reinforcement learning is a subfield of machine learning concerned with training robots or agents to take optimal actions in an environment. The environment is any task which can be represented by some numerical state or observation, and where the agent's performance can be measured by a reward function. The agent has to understand which actions to take in order to achieve the maximum reward. So how can we train an agent to understand this relationship? Well, for this, a reinforcement learning algorithm is needed. In this project, I used an algorithm called Deep Deterministic Policy Gradient, or DDPG for short. The algorithm consists of two neural networks, a critic network which predicts the value of a state, and an actor network, which decides the agent's next actions. The critic network is not used for completing the task itself. However, it is crucial during training, as the actor network actively tries to maximize the output of the critic network, because the critic network becomes a proxy for the reward from a state, and it is the reward which we want to maximize. However, we can't rely purely on the agent's own actions. Otherwise, the agent will be stuck following one strategy, losing the possibility of finding new, better solutions. On the other hand, by actually exploiting the environment, the agent achieves the highest currently known reward. So it's a question of long-term versus short-term benefits, and a balance has to be achieved. My approach to the problem was to implement epsilon-greedy exploration conditioned by reward. The level of exploration is determined by the parameter epsilon. When its value is 1, the agent explores 100% of the time, at half, 50% of the time, and so on. At the beginning, the agent strategy is poor, so epsilon is set high. It is only decreased when the agent starts achieving higher rewards, as then we can be sure that its strategy is improving and the agent needs less exploration. However, a small amount of exploration is still beneficial, even if we are exploiting the environment. Therefore, noise was added to the agent's actions to boost exploration. The final action decision process can be represented in this form, with the variable p being a randomly generated value, determining whether the agent explores or doesn't at this specific time step. With a proper reinforcement learning algorithm and an exploration strategy, many problems can already be solved, although for more complex tasks, the training process would be unstable and incredibly slow. That's why I implemented experience replay. Experience replay is a buffer which stores previous information, like the state, action, and reward. It accelerates training due to the correlation of training data, and by using collected samples multiple times instead of discarding them after one parameter update. Moreover, experience replay stabilizes training by combining old and new information, which reduces the risk of policy collapse, a situation where the agent rapidly forgets the learned policy with the introduction of new information. So, can we actually train a successful agent with all these algorithms and techniques? Yes, we can. On the graph above is the reward for the trained agent, as well as a random untrained one in the grouper push environment. In this task, the agent is required to push a cube to a target position in as little time as possible. Before training, the agent achieved a reward of -51. However, afterwards, this increased to -18, a 175% improvement. However, this progress is best seen on the actual simulation. So here's the agent before training. And here's the agent after training. Grouper push is not the only environment I train an agent on. Grouper rise tasks the agent with lifting a cube to a target position in the air. Here again, we see a massive improvement in performance, with the reinforcement learning trained agent achieving a reward of -9.5 compared to -24 achieved before training, a 150% improvement. Once more, however, this is best seen in the actual simulation. So here's the agent before training. And here's the agent after training. As could be seen from demonstrations from both environments, reinforcement learning is a powerful method for training and controlling robots. The future of science and industry will be driven by automation, and I believe reinforcement learning is the perfect tool for leading this trend. Thank you.
So here we got another returning candidate here.
Hello.
How is it? You just came back from the room. Like we were talking a bit before about like this feeling that you can have when you're on stage in the dark and everything. Tell us a bit more about it.
Yeah, so it's so much different being like waiting for the moment and actually being on stage and presenting. It's like the difference in experience is quite huge. So I think when you have the time to kind of stand on the stage for like a few minutes, you get you get slightly used to this experience, and I think so. This year I was a bit less nervous than.
Do you think it's a comforting experience?
I would not call it a comforting experience. I think whenever you're presenting before someone who is gonna judge you, and that's their job, you have this pressure on you to present in a professional manner, and you have this slight feeling that maybe if you fail or if you do something wrong, then it might have an impact on your performance.
I see. However, I believe there might. Well, I've never done a contest like that, so you have more experience than me. But like, tell me, is it different than to actually go in front of a teacher, for example, at school and present your projects? In my mind, here you're actually presenting something that you love, that you've been working on personally with your own decisions, when in school or for an interview you actually need to work on something that people ask you to work on. You know what I mean?
Yeah.
Does it make a difference here?
It does make a difference. I think here the motivation is so much greater, right?
Is it? Okay.
It is, and you have this feeling, this motivation to actually prepare, to study, and just have to give your best. And so, in some sense, if you have this confidence, then yeah, it is. Sometimes it is probably maybe better than in school. Although in school you know everyone. So,
Yes, true that.
and maybe the attitude is different because grades matter a bit less.
Okay. Okay. And then, so last year you presented already some projects related to machine learning, and what was your motivation to come back this year, and what did you change? What was different?
I think that just about my interest in machine learning and some way to have some value out of it, some tangible value out of it, like earlier on. So this year I've changed. The theme is the topic is
it's a different
completely
topic.
different.
Yeah.
So last year it was more based on the environment. Now it is more robotics, and the way of actually implementing the algorithms is completely different.
Okay.
Last year it was a thing called supervised machine learning. So then you have a data set, and you just train on this data set. No extra steps.
Okay.
Okay, simplified. No
Yes,
extra
of
steps.
course. Yeah, we.
With this year's project, you don't have any data set.
Okay. Okay.
You just have a task, some environment, which we call it, and you just see what is there.
Okay.
You look at the environment, and based on what you see, you learn.
Okay.
You do something. So, for example,
Is it a bit like how AlphaGo is trained, where you just give him the rules and you let him play till he gets the thing?
yes,
Okay.
yes, that's also reinforcement learning.
Okay.
And that's the same idea.
Okay.
That you give it, for example, the board of the game of Go, and the algorithm sees, okay, I moved this piece to this position.
Was
and
it a
later
success?
on, I lost, for example.
Okay, yeah,
So
yeah.
maybe it's not a good idea to do this. And if you do it for
Ever?
for thousands of steps,
Yeah.
millions of steps, as in also the case of AlphaGo and many of the most complicated environments, you achieve some like great results. So I think Dota 2, StarCraft, these are like complex strategy games.
Yes.
The reinforcement learning algorithms achieved like extraordinary results.
I'm a StarCraft 2 player, and I encountered once that bloody robot. It was a terrible experience. But do you think you're going to come back next year with another project all related to machine learning and keep on doing that? Would it be something for you, actually?
Yeah, so I thought that because I do think that actually combining machine learning with some engineering is super interesting. Although currently I'm mostly focused on like purely software, so machine learning by on its own. But if I could learn some electrical engineering in this year, I would be really happy to present something like physical. If I don't manage to do it, then probably I would keep on advancing and developing my skills in, for example, reinforcement learning, because I think that's the most interesting
Will
part.
ChatGPT be able to write your report next year?
Well,
a very wrong idea.
Yeah, so
Forget about that one.
well, I mean, I will not use it.
No.
I will not use it. I do have this idea that I want to be able to write.
No, but
myself,
it's the stress that basically all those topics, because it's a galaxy of topics, and they are more or less related. Like in the end, there are very different topics within this galaxy here, but we see that it's a theme that's coming like really, really strongly. We see more and more people talking about it on the news, and so I think you're choosing a right path here because there is plenty of future in that range. That's what I'm trying to say here, definitely.
Although I have to, I do understand the concerns. You have to be careful what you do with AI, because when it's done badly, it can have awful consequences. So it is this kind of balance. Although I strongly believe that if you implement it correctly, use it in the correct manner and the correct use cases, then it can have like great benefits.
Oh, absolutely. I remember the time when Wikipedia started and got launched, people got really scared and said, like, people at school are not going to work anymore. They're just going to copy Wikipedia. And then in the end, we noticed that people are just using it as another tool in their tool set. So I'm not sorry about that. But I'm very happy that you came back this year. In any case, I hope you had a really great experience because it's only starting by now. This is just the beginning here, and and hopefully see you next year, fingers crossed.
I think I will come up with something.
That sounds good. Thanks a lot for your intervention here.
Thank you so much.